So Zabbix Loadable C modules and Low-Level Discovery. I was considering putting the whole talk just into the title, but I thought this will keep it a bit shorter. So I'm Jan-Piet Mens, I'm JP Mens. Amongst a number of other things, I created a project called OwnTracks, which one or the other of you might have heard of. We produce or we create open source tracking applications for mobile phones, iOS and Android. And it's completely open source. You host it yourself. It runs over MQTT or HTTP. I'm telling you this as a prelude to what's coming. We don't know where you are, of course. This is purely hosted by yourself. I'm showing you this map because I assume you're about as short-sighted as I am, so you can't see the details. This is where my family is. And they track me, and we track each other. And this has become relatively popular. So we created this project. And another project that we created was OwnTracks for vehicles. And what we do with OwnTracks for vehicles is we have devices. These devices, approximately the size of half a package of cigarette, a bit thinner, which communicate over TCP to a piece of open source, and from there onwards via MQTT into all sorts of other infrastructure. And what we wanted was a mechanism by which we can monitor particular vehicles. However, what we did not want to do was to create a vehicle manually. So our monitoring system of choice became Zabbix. Now, the reason it became our monitoring system of choice, a number of reasons, but one of the main reasons is it's very extensible. And as Dimitri, to my mind, rightly said earlier, he's the expert, I'm not. I just fell in love with one component, and those are the loadable modules. Otherwise, I'm not a specific Zabbix expert. As Dimitri rightly said earlier, if you were listening to his talk, Zabbix is very extensible. We can get all sorts of data into Zabbix, and I'm going to show you maybe something that is a little bit less well known, and those are loadable C modules. So Zabbix, out of the box, cannot possibly support everything you want. There is a lot of support for a lot of different components, but we can extend it via a number of different possibilities. And I'll show you 4 of them: the system run user parameters, so-called external checks, and loadable modules. The first 3 are extensible or possibilities of extending Zabbix via basically executable programs, so maybe a shell script, a Ruby program, a C program, whatever. And in these cases, we have to be a little bit careful because either the Zabbix server or the Zabbix agent, depending when this is where these things are running, and I'll tell you a little bit more about that in a second, will cause or can cause severe load due to the fact that these processes start forking and executing executables. The last mechanism here, so-called loadable modules, is slightly more complex. Loadable modules are created currently in the C language, so a little bit more complex. But I would like to introduce you very carefully to that and show you a small, relatively trivial example, which I hope will demonstrate or at least illustrate what we're doing. So system run runs on an agent. System run, you basically have system run in here, user local bin, whatever, 1, 2, 3. And this is basically a shell script. It can be an executable program, whatever, Ruby, Perl, doesn't matter, Python. This is run periodically. The system run runs on the agent, and the agent then returns this parameter back under the appropriate key to the Zabbix server. System run must be enabled by enabling remote commands and optionally logging remote commands, and these commands are then logged in the normal Zabbix log. Another possibility, again on the agent, is so-called user parameters, where in the agent configuration we configure a user parameter, for example, name.cn, whatever, and then a shell script or shell line, which is executed there. This is something I'm very wary of doing. I feel this is a little bit brittle. Logging is not as good as I would hope it would be anyway. But this is something that everybody can very, very easily do to extend the agent. On the server, we have so-called external checks. These external checks here, once again, are, for example, shell scripts or Ruby programs or Python, whatever, which can be parameterized. And these programs would produce standard output, and the standard output is then consumed by the Zabbix server, and that turns into metrics. Here, these external checks, once again, run on the server, and there is an external script path which needs to be configured, and in that path, in that directory, that's where you would place your programs. So these are things which have existed for quite some time, and what has also existed for quite a number of years are loadable modules. And loadable modules are currently written in the C language. I say currently because Zabbix has, help me Dimitri, I think in 4.4 introduced an agent in Go, to my knowledge. No guarantees, but to my knowledge, there is currently no loadable modules for the Go. I understand one is still thinking a little bit about it. So loadable modules are written in C language. They are thus compiled. They are dynamically loaded. And they can be loaded. They can be read into the server, into a proxy, or into an agent. And the agent, that's where, that's the point that interests us particularly much. So what can these modules do? Where can these modules obtain metrics from? Well, actually, just your imagination is the limit. Basically, these modules, since they are C modules, C functions, they can do whatever you like. We could access sockets. We could access System 5 IPC inter-process communication. We could access files, databases, any communication protocol you want, IoT, sensors, Dimitri's CAN bus thing, what do you call it, ELM, what was the number? 214, 759, whatever, exactly. And so these loadable modules can basically do anything that a function in the C language can do, so de facto anything. The only thing we need to be slightly aware of, or we need to be a little bit careful with, is first of all, the loadable modules are loaded into the process of the agent, respectively the proxy or the server. That means if a programming error causes the module to crash, then of course that would take down the whole agent or the whole server. Well, one has to be a little bit careful. Testing is a bit more, maybe a bit more intensive. And we're running in the context of a Zabbix process, be it the agent or be it the server or the proxy. And thus we have to be slightly careful with that and with permissions. So let's have a look at how a custom module is configured. First of all, we have a path. So Zabbix will only load a module if we have a load module path configured. That means in/user/lib Zabbix agent, that is where these modules are to be found. They're shared objects. I'll show you in a moment how they're created. And we can load basically any number of modules. Here I've got an example, an OwnTracks module.so.shared object, and another module 2.so. So the Zabbix would load these two modules in sequence and would provide whatever functions are contained in that module. These modules are, as I mentioned already, they are C programs which are dynamically linked. This is a makefile which would create that. So we have here our file called OwnTracksModule.c, which is compiled as shared code. Out of that comes a .so, a shared object, which is then installed or copied into the appropriate directory. Okay, so that is how we would build these modules. Zabbix modules, Zabbix loadable modules, can be built in the Zabbix source tree or outside of the Zabbix source tree. I personally prefer building them outside of the Zabbix source tree, so that I have my own directory, my own configuration, my own documentation of it, etc., my own makefile, and I can build them irrespective of the actual Zabbix release and version. And in order to do that, I have a module.h file, which I copy in to my code. And the only thing we have to do, this is the module.h file, which is provided by the appropriate Zabbix release. And we just have to change this line by these two lines, that's all. So we copy that into our source code, and into our source code directory, and then from then on we can create these modules. The module itself can have a number of functions which are invoked by Zabbix. There's one mandatory function, and that is the function ZBX Zabbix module API version. That module must exist, or I beg your pardon, that function must be defined by my module. All others are optional. However, if we only have the module API version function, then our module will de facto not do anything except provide a version number. That's all it provides. And we'll look at the others in a moment. The function ZBX Zabbix module history write callback I've stricken out here. It still exists. It is documented, though very, very badly, or very summarily. And my recommendation would be not to use that. There's an alternative capability, and I'll show you in a moment what that will be. Beg your pardon. Module init will initialize our function, or will initialize our module. This is where, for example, I could open a socket connection to something. I could open a database. Module uninit will sort of de-initialize. That is when Zabbix is going to unload the module. In other words, Zabbix is terminating, for example. I have the possibility to clean up things. And module item list is where we will get we will define a table of keys, so-called Zabbix item keys, to functions. I'll show you in a second. So let's look at this. We have, in certain cases, we return values. Be please very, very careful with string values. String values are, we always return a copy of a string value. This looks a bit strange if you are a C programmer, or if you're used to looking at a bit of C program, returning a copy of a string is always a bit difficult because you need somebody to de-initialize that, to free it. Zabbix does that for us. That's a little bit it's difficult to get used to, but that's the way it works. So our C module starts off with an include on our module.h, and here we define the sole mandatory function, Zabbix module API version, and the only thing we do is return this constant. The reason this exists is so that when, for example, a future Zabbix version would load my compiled module, which I haven't recompiled, I've compiled it today, and a future Zabbix version might have a different API version, Zabbix could then warn me and say this API version does not match the code that I currently have, so I have to recompile or maybe also redefine, okay? So this is the only, or the single mandatory function. And basically you just copy these four lines in there. So what do we then have? The initialize, respectively de-initialize, or init and uninit functions. What I'm doing here is I open a database and set a global, and upon shutting down, I close that database. That's all I do. That's all I have to do in this particular very, very trivial example. And other than that, we return an OK, respectively a failure code. If we return a failure code, Zabbix will not have loaded our module, or in other words, has tried to load the module. The module has said, we can't find the database, so Zabbix will then stop with an appropriate diagnostic message, which is correct. Then we have the Zabbix module item list function. The Zabbix item module list function, it will return an array of structures, and these structures define an item key, a so-called Zabbix item key. The Zabbix item is like a field. Whether or not the function gets parameters, so I've named the key ontracks.ping, that gets no parameters. Ontracks.LLD, low-level discovery, gets no parameters, and ontracks.vel, velocity, that gets parameters. Okay, the actual internal C function, which we'll see defined in a moment, these are the names of the C function, and appropriate test parameters, which are used, I've forgotten, I think they're used when one starts Zabbix with -p. That's sort of a test to test the internal module. just an example. And this, the function onTracks_vel velocity will be getting an EMI number, an International Mobile Equipment Identifier, and that is how it will determine which vehicle is being queried, but I'll show you that in a second. So these are the names that Zabbix is going to query, or we can have queried in Zabbix, and these are the appropriate C functions which will be invoked. As a small example, let's look at this function. Let me just go back. This function onTracks_ping gets a Zabbix agent request and a pointer to results. The only thing that this function is going to do is it's going to copy a result, here the integer 42, back to Zabbix, and then returns with an OK value. Okay? So Zabbix will, every time that this function is invoked by the item onTracks.ping, is going to invoke this function onTracks_ping. That function _ping is going to return the value 42. And we can test that after restarting the appropriate agent or the server. We can test it, for example, with Zabbix get on the server, respectively agent name, with a key onTracks.ping, and we see the value 42. Any Zabbix key that you can query, ours is called onTracks.ping. So these items that we have created, they can be loaded into the front end, and on the front end, we're going to create simple checks, and we're going to do that for Zabbix agent, respectively active agent. And these items we can, on the front end, we can of course create, for example, programmatically, either in the user interface or using, I've just used an example here because I'm a great fan of automating things, so creating an item programmatically with the API. And you see the key, the field key is onTracks.ping, and that is what is then literally copied into the key. So whenever this field is invoked, every here 60 seconds, as defined by the delay, then that field will be, or that key will be invoked. Zabbix knows that key because it has loaded it during the server start and respectively agent start, and knows what to do, and will actually invoke that and return that value. So let's look at a little bit more complex function, and there is the onTracks.velocity. You will recall, let me just go back 3 pages. You will recall onTracks.velocity was a function onTracks, or invoked a function onTracks_vel, and got parameters. Let's go forward and look at this function. Basically, the function header, the function signature is identical. And what we're doing here is checking whether we actually have a request parameter. If we have no request parameter or more than one request parameter, we return with an error message. And this error message will be then made visible in the user interface. In the Zabbix user interface, I'll show you in a moment, that error message would be seen. And here, recall I said we always return a copy of the string. This is an example. We return here the error message, string dubbed, so a duplicate, a copy of the string. Other than that, what this function does is goes into the database, looks for the appropriate parameter, and then returns a copy of that value. And this function onTracks_vel velocity will be returning the speed or the velocity that appropriate EMI number is driving at. So what we now so far have is a C module with a number of compiled functions, which has been loaded by the agent, respectively by the server. And these functions can be invoked by calling them with the appropriate parameters, just like we would any other Zabbix function. Okay? So far, there's nothing really special. The only special thing is basically that we have this data being returned by a dynamically loadable module, which we've compiled from a C source. So very fast and contained within the server, within the agent. Now let's talk a little bit about low-level discovery. Who of you have already heard about low-level discovery in Zabbix, generally speaking? No? Okay. So low-level discovery is quite widely used, and there are a number of built-in mechanisms or built-in methods which Zabbix has to provide low-level discovery. For example, network interfaces or CPUs or SNMP OIDs can be returned through low-level discovery. So-called JMX objects, we can have ODBC queries. Who uses ODBC? I get shudders when I hear ODBC. Windows services, file systems, things like that, Zabbix can return with low-level discovery. Now, the interesting thing about low-level discovery is that we can add our own. So it's basically no limit to what we can discover. And that is what I'm going to show you here. Now, the way that low-level discovery works is that we create an item in Zabbix, a so-called trapper item, can be any kind of item, for example, a trapper item, and we push into that item from outside, we push JSON in a very specific format, which of course Zabbix supports. And the fact that we are putting or copying JSON into that trapper item will cause Zabbix to create new items, new graph items, new templates, whatever. So low-level discovery discovers entities and not actual values. So what we're going to create with a low-level discovery is, in this particular example, for our particular use case, is since we're monitoring vehicles, we're going to create new vehicles. Anytime a new vehicle shows up, anytime we configure a new car, a new truck, a new bus with one of these devices, gets an EMI number. This EMI number is published via MQTT to a specific broker, and Zabbix will then automatically get that EMI number and will create an item for that EMI number and for the number pad of the device. I'll show you in a second. So the way we do this is we have vehicles, buses, cars, automobiles, any vehicle with these devices, with these Q-trip devices. And what we do is we get that data provided by these devices. The data is published typically once a minute, respectively every 100 meters, or when a car turns a corner. Whenever the GPS system detects that it's going around the corner, then we automatically publish a new message. And this data is going to be picked up by a process that we've created. This process, I'll show you in a moment what it does. But amongst other things, it's going to feed an LMDB database. LMDB, the Lightning database, originally created by Howard Chu for OpenLDAP, is an embedded database. It's very, very fast, it's blindingly fast, and it's relatively easy to use, and it's embedded, and that for us is ideal. So basically, it's attached to our C module, which has been loaded in the agent. Here on the left-hand side, we have our Zabbix agent on each of the servers that we want to use. We have this agent. This agent has our dynamically loadable C module. This dynamically loadable C module reads the LMDB database and will then provide data and values to the Zabbix server. And amongst others, it will not only provide the values, for example, what is the velocity of EMI number 1, what is the velocity of EMI number 2, but it will also provide low-level discovery information, which it gleans out of that LMDB database. So what this process that we have here, this blue process, what that does is it subscribes to an MQTT channel and reads all topics that are coming out there. It extracts our own tracks JSON payload. I'll show you an example in a second. It updates the device store, so it basically creates an entry in the LMDB database for low-level discovery. It will also this process will also determine when a device, for example, goes dead. It will remove the entry. It will, as soon as it updates the entry, it updates also time to live. That time to live is automatically decremented later on. And what we also store in the database are device details, which can be picked up, for example, by our own tracks_vel function to determine the velocity or specific other data that we want monitored. I'm just showing you the velocity here to keep it simple. This actual process is about 120 lines of Python, so it's relatively trivial. So how do we use LMDB, and why did we use LMDB? We use it because we are in process. We would need to subscribe otherwise from multiple agents. It will be difficult to determine which agent has got which value. And what we have here is with LMDB, we have a single writer, that is the process, and we have multiple readers, those are the agents, so perfect for us. No additional moving parts, so we keep things as simple as possible, and we are very weary of moving parts. Moving parts always cause, well, movement. And in LMDB, we have multiple language bindings, so we can, for example, write from Python or read from C and in multiple other languages. The actual data, the actual payload that is in the database looks like this. We have a device which is sent out with an EMI number, and we have a JSON payload, which I formatted here so that you can see what it looks like. This is the original payload format that we also use on our apps. So we have JSON with a location type, we have a timestamp, latitude, longitude, course over ground, altitude, velocity, a so-called tracker ID, battery level, and an additional name in the particular case of a vehicle. These are usually, if the customer wants it so, the license plates of the vehicles, which for the customer is normally something that is that defines what it is. And this payload has been meanwhile adopted by quite a number of open source projects. For example, Home Assistant, OpenHAB supports our OnTrax payload, etc. So this is the payload that then is entered into the database. And then we go and define the so-called low-level discovery in Zabbix. Upon defining low-level discovery rules, we can then later on create item prototypes, and we can create graphs, for example. We can create triggers. Here is a trapper item as an example. We have a trapper item which we create, Zabbix type trapper, key name my item. I'll show you a different one in a moment. And we can send out to that server this item name, that is that item. And the data that we send out is a JSON blob. So JSON is an array of JSON objects with macros. This thing here in braces, brace open, hash, brace close, brace open, hash, brace close. Inside there is a macro name. And what we have called it is simply OT for OnTrax. And then we do the EMI number, that's the International Mobile Equipment Identifier. That's the unique number of the GPS tracker. And for example, the plate, the license plate. Okay? So this data that goes into Zabbix will automatically create an item, discovery item for this item with the EMI number 012345 or whatever. So this JSON format, that is something that has been defined by Zabbix, and the only thing we have to do is to adhere to it. We can send in any number of macros with any number of values, and these macro values, we'll see in a moment, we get back. So this JSON format, we can also, of course, provide for from our loadable module, and that is what this function does. You recall we had that defined. OnTrax.LLD is the key. OnTrax_LLD is the function name. And what we do here, I'll make it simple, what we do here is basically create, let me just go back a second. What we do is create this data structure, this JSON data structure from all devices in the database. So we would create an array of objects, of JSON objects, which contain OT EMI and OT plate number for each of the devices that we have seen. We return a copy of that, and Zabbix will then consume it. So we have a discovery rule, here Zabbix agent, running on the Zabbix agent. The key that we're reading is OnTrax.LLD, which will expand into this function. So that's where the data is coming from. Zabbix is going to read this every 120 seconds. That's what we've defined. So every 120 seconds is going to invoke that function. That function is going to produce JSON. That JSON is read by Zabbix, and Zabbix is then going to, from that, create with prototypes, going to create triggers, for example, it's going to create items, going to create graphs. A marvelous feature of Zabbix is we can say keep lost resources period, and it's set here to 3,600, and that means the following. If our low-level discovery rule or our low-level discovery item no longer, for 3,600 seconds, no longer provides a particular entry, for example, for a vehicle which doesn't exist anymore, then Zabbix will automatically expire that and remove that entry from its database and from its interface and from its database. So that's a really very nice feature. What we then do is create item prototypes. Here, key onTracks.vel velocity, that was that key that we created, and we pass the EMI number. Okay, recall please that this data comes from here. So we are using this macro, ot.emi, so later on the user interface, we can see this EMI number, and then of course the plate number. And the name of the entry or the name of the type is EMI $1, that is that number, and we see here the plate number. I'll show you in a moment what that looks like. We can create trigger prototypes, for example. Here's a trivial little example where I send out a warning. If, here's the rule, it's very hard to read there, that's why here larger. If onTracks velocity for a particular EMI number, the last velocity gleaned is greater than 90 kilometers per hour, we send the velocity in kilometers per hour, then we would alert, we would trigger on that, okay? And this, of course, results in a warning, for example, speed of license plate 7293FQ, is probably, it looks Dutch. Speed of that vehicle is greater than 90 kilometers per hour. So, low-level discovery in action. After a few minutes, our functions have produced low-level discovery data, which Zabbix has consumed. It automatically creates the Zabbix prototypes, and we see here the individual devices, EMI with that number and that plate, EMI with that number and that plate, etc. We see all these devices that show up in the user interface and are being fed by the Zabbix agent, or by a Zabbix agent, or by a number of Zabbix agents. And recall, these agents are reading the database from by a dynamically loaded module within Zabbix. And this is really a very fine, very fast, and very efficient mechanism of doing this. Much, much more efficient than if we started forking and creating external processes to do this. What we will then see is that if we look at latest data, for example, we see the individual devices and, for example, the last speeds. Yeah, the graphing is automatically handled by Zabbix, etc. We don't do anything there. Zabbix does that for us. Here's an example of a device. This number, which I can't read here, doesn't matter, has reported an error and a warning, and if we look at that warning, the item is not discovered anymore and will be deleted in 57 minutes and 45 seconds. Okay, so during the last run, Zabbix got the low-level discovery data from that JSON that we produced. However, the element for this EMI number, there, 56 or something, can't see it, was no longer in the data set. So Zabbix is warning us, and it will automatically expire this item and all its data after, in this case, 57 minutes, which for us is excellent because we have devices that come and go. For example, if a device goes offline for a longer period of time, then we don't want to be alerted for it. It should just sort of disappear. Yeah? Or if a customer decides to trash or to replace a device, then we don't have to manage it manually. It is managed, so to speak, automatically. Graph prototypes in the discovery system also enable us to create graphs automatically. We just create a prototype, and Zabbix will automatically start feeding these graphs as soon as new devices show up. So this also for us is something that is hugely useful and hugely practical. So what we have now seen so far is a loadable C module with a number of functions. One of these functions has produced a JSON array with data elements which Zabbix consumes, and after consuming it, it then starts going out and queries our same loadable module for the actual data that it's going to use in, for example, in creating prototypes and creating graphs and creating data. What is also interesting is what we can do. I wouldn't recommend it, but what we can do is history export also via a C function in our loadable module. This only works if the module is loaded on the server. It does not work if it's loaded on the agent. It is quite complicated, and not to say very complicated. It is rather badly documented. Probably, or possibly, I don't know, but possibly because almost nobody uses it. It's invoked at server start, and then periodically, for example, documentation, it is not exactly specified when it is invoked. It is just periodically invoked. The good thing about history export is we can replace it by a so-called real-time export into JSON files, which Zabbix already supports. So let me just show you a very, very small excerpt. As you see, it's incomplete here. A very, very small excerpt of this function module history write callbacks, where we define which fields we want to actually write. We have to say, I've got an integer and I've got a string. We need, for the individual integers, we have to go through from 0 to history count. We sort of work through Zabbix internal history information, which defines how many values it actually has. This is very, very error prone, and I would really not recommend you do it. Instead, there's a functionality called history export, real-time history export, which writes out into JSON files. It will rotate these JSON files also, and then we just have JSON, which can be processed with any JSON-capable tool. You can look at it with JQ or handle it with Python, or with C, or whatever you like. So here we have an example that field we had earlier, jolie.cn, was one of our external parameters, or user parameters rather. We have a clock, that's the epoch timestamp, the Unix epoch timestamp, and the actual value. And here, for example, we have an application file systems and the item ID, that's the item within the Zabbix interface. So we will get everything, all the values, all the settings, etc. Okay. So that is history export, if you want bulk and real-time export of the Zabbix data. Right, I'm almost done because I'm the only thing that's standing between you or us and I think the beer. So I'll get it going. If you care to look at this more closely, it's this is basically what needs to be done, a low-level recipe, if you like. You write and compile and, of course, test your C code into a module. You edit the configuration. You specify that the module is to be loaded. You restart the agent, the server, or the proxy, depending on where you want this module loaded. You create your items, and Zabbix then goes out, gets that data, and uses it. It is quite difficult to crash a server. So it's not really not something that will happen very quickly, very easily. And of course, you might also ask, why should I do this? In my opinion, C functions are extremely fast. It's currently the fastest mechanism to get external data, unless you're writing into it, unless you have trapper items. The C functions are very fast. Low-level discovery is highly flexible. We talked shortly about the fact that Zabbix internally uses low-level discovery, for example, for file systems or network interfaces. And I hope I've illustrated how we can use low-level discovery basically to discover anything, yeah, to discover anything. Dimitri was saying earlier that he was using something like a trapper item, for example, to get the CAN data, the OBD data into Zabbix. This would also be a possibility. Not only a possibility, but a highly efficient possibility. So together, this is a very powerful combination, and in addition to the Zabbix API, which lets us, for example, create items or graphs or whatever from outside, this is really a very, very nice thing. Unfortunately, this API has no support for logging and no support for reading Zabbix.conf. So it would be very nice to be able to have own configuration parameters for whatever functions we have. It would be nice to have them in the same Zabbix.conf, which we possibly deploy automatically, etc. But there is unfortunately no specific API to read that. There's also no logging API. So your C module would maybe use syslog or static files or something like that, or IPC or whatever, to get rid of logs or to produce actual logging. Documentation is slight, but it's readable, and there are a number of examples, and you could use this as an example to get started. And yeah, that's about it. Thank you.